So good morning, everyone. Director Franz De Leon, Ms. Joanna Suhico, and other members of the CSD and ASTI, distinguished guests from various institutions in the country. This morning, allow me to present an overview of the Philippine Sky Artificial Intelligence Program, or SKAI-PINAS, and also present some outputs of the work that we're doing. So I am Dr. Joe Rubrico, and as mentioned earlier, I was a balik scientist of the DOST-ASTI almost 7 years ago. All right, so my work in the DOST-ASTI half a decade ago was in grassroots artificial intelligence and robotics efforts, okay? And this spawned two projects, prototypes, if you will, the Automated Labeling Machine, which is the ALaM project, and the AI robot project. So the ALaM project is basically concerned with the automated identification of natural and man-made objects in satellite images, while the AI robot served as a prototype for exploring concepts in rescue and recovery robotics and edge computing. So eventually, the ALaM project became the SKAI-PINAS program, and the AI robot became the ASIMOV program. Okay, so the Philippine Sky Artificial Intelligence Program has been implemented for a couple of years now, and in its third and final year of implementation, it has been reconfigured to be implemented back in the DOST-ASTI, administratively through the ASTI-ALaM project, which is led by Dr. Franz De Leon. So why SKAI-PINAS? So when this was first conceptualized, and even until now, the Philippines really has a lot of data, especially in remote sensing, be it from satellite imagery or LiDAR. Okay. Especially now with the institutionalization of the Philippine Space Agency, or PhilSA, our data is just growing and growing. Now, traditionally, the way you process this data is to have a small army of people and manually try to distinguish or label the features to use for various remote sensing applications. Now, the question is there a way to do this so that you have more with less? Okay? And so the solution that was forwarded is to have AI in the loop. Basically, you have AI-based processing that takes in your inputs, satellite imagery or LiDAR data, process it, and then have your outputs, whether as your final end products for end users or as intermediate outputs that can be used in the workflow of software developers for remote sensing applications. So, in a nutshell, the ALaM framework is composed of enabling technologies and resources with the intention of making the process of developing remote sensing applications easier and more efficient. So, for example, what can we do with the models? They can be placed in the workflow so that they can automatically detect features of interest. For example, tree cover, volcanoes, marine features like corals, coral reefs. Okay? Or you can also use the labeled images, the data sets, to train models, refine models, or they themselves can be used in other software applications. So the program functionally is composed of two components. The ALaM LSI component, which is the concerned with the large-scale preparation of training data sets and the implementation of AI models, and the ASTI-ALaM component, which is involved with the full-scale training and optimization of AI models. So the ALaM LSI component is being implemented in Davao City, and I'm leading that, and the ASTI-ALaM component is implemented in Quezon City and led by Dr. De Leon. Okay, so now I'll go to a quick presentation of our outputs. So as far as large-scale data preparation is concerned, we now have now been able to prepare around 5 million objects, okay, so which can be used to train AI models or be part of software development workflow. So basically what you see in the screen is an image, a satellite image or drone image, and then they are labeled according to the features that you are interested in. So the 5 million objects include tree cover, greenery, crops, built-up structures, man-made objects, geological formations, clouds, marine features, among others. So we also have developed 100 plus AI models for various tasks, as you can see on the screen. And we are continuing our training to develop even more. So on the screen, you can see some AI models being used to segregate certain features like different crops, identify man-made objects like vehicles, etc. Okay, so the next update will be on AI-enhanced labeling. So I'll just play the video. So essentially, when you label, it's a very manual and meticulous task. So the idea of AI-enhanced labeling or AI-assisted labeling is to put AI in the loop so that you are able to to process more in a faster manner. Okay, faster, process more quickly. So essentially, we have AI models that help out in the labeling process. So that 5 million, we are hoping to add a few more million to our labeled objects by utilizing these kinds of innovations. So in this video, okay, sorry about that. So in this video, we can see that a coral reef is being segmented automatically. Okay, and if a human does that, it usually takes a lot of time and it is very, very tedious. But we will treat this as like when AI is applied in diagnosis, there will still be a human in the loop to quality check. But you know, AI can help out a lot to speed things up. So this is the idea of AI-enhanced labeling. This is a demo of the capabilities of some of the AI models that we developed. So here's another video. So depending on the feature of interest, the AI models will segment, detect, or classify features. For example, these are coral reefs, okay, being segmented by AI. These are coconut trees being segmented by AI. Okay, automatically. And we also have ones for object detection, basically kinakahon niya. Okay. Instead na tinitrace niya, kinakahon niya. Okay, and again, these are coral reefs. Right, and these ones involve different crops. So this one is a case of image classification. I cannot really identify what that is, but according to the models, that's a car. So it was trained on that, and that was a car when it was trained. Ito clouds. So according to the models, those are clouds. So in order for these products to be accessible to internal and external stakeholders, we are also doing portal development where we may be able to share these things, okay, to various stakeholders. So the one being developed by ALAM LSI usually caters to internal stakeholders like ALAM LSI, ASTI-ALaM, where we can share data sets and models, and also with some institutions that we already have collaborations with. So right now we have the basic functionalities which are constantly being improved. Okay. And of course we have the DIMER portal, which is developed by ASTI-ALaM. Okay. And this one caters more to external stakeholders, meaning projects of the program like government institutions, maybe private institutions, and the like. And this is primarily for model exchange or the use of AI models. So this one is already up and running, I think. I'm not sure if this has been rolled out already, but this was launched September 2023, last year. All right, so finally keeping true to our mandate of grassroots development, we have held internships in the program, and so far we have trained 50 or so undergraduate and high school students from different institutions, the Philippine Science campuses, UP, some universities in Mindanao, USEP, and even from Silliman University, which is in Dumaguete City, okay, Negros Oriental. All right. We are also looking forward to graduate students getting involved in the efforts to use the outputs, and of course, the different agencies and stakeholders through the ASTI-ALaM component. So with that, I thank you for your attention.